Hey students, welcome back. This is 7.4. We're going to talk about acids and bases. So we're shifting gears a little bit away from solutions and now we're getting into acids and bases. So real quickly, I think our page number's wrong. I think we might be on 45, but do whatever number you got rolling there. Okay, so we're going to start, like I said, with acids and bases, and we're going to go ahead and start with a definition. So there are actually 3 different definitions of acids and bases, but we're only going to talk about 2 of them. In higher level chemistry classes, you might talk about Lewis acids and bases, or you might not. So we're going to leave that one alone for right now. So our earliest definition was the Arrhenius Theory. Arrhenius actually did a lot of work with solutions, and he was the first one to coin the term acid and base. So what his definition was that an acid was one that produces H plus in solution. So it produces H plus in solution. So when we put it in solution, it made an H plus. That's what his definition was. Then his base, he said that it produces an OH minus in solution. And this is actually where he kind of got into trouble and it didn't really work out for all things, which is why they had to edit it and come along with a different definition. So our next definition is our Bronsted-Lowry theory. And this is the one that we're going to use most often. And this is the one that we're going to base all of our other stuff off of, so just be prepared for that. So Bronsted-Lowry came along a little bit later and they defined an acid a little bit different, and they said that an acid is one that donates a proton. And in this case, they're thinking of a proton as an H plus. All right, so it donates a proton, so it gives up an H plus. And then a Bronsted-Lowry base is one that accepts a proton or takes on that H plus. So you kind of have to follow the path of the H in this case to kind of figure these out. There are some other vocabs that go along with these Bronsted-Lowrys, and we have our conjugate acid. This is the former base. This was the base. And this is the one that accepted the H plus. And this is going to be a product. It's going to be found on the right side of the arrow. All right, so this is going to be a product. Then we have our conjugate base. So this is our former acid. So on the left side, or on the, on the reactant side, this was the acid. So this is the one that donated the H plus. But again, it's on the product side we're talking about. And then here's our key. A conjugate acid base pair is one that only differs by an H plus. So we're talking about it only being different by an H plus, and we'll kind of see how that works down below. We're just trying to get some vocab out of the way here. Then we have this fun word called amphoteric. Amphoteric, just like our prefix on an amphibian that can live on either land or water, right? Amphoteric is very much the same way. This means it can act as an acid or a base. So it can act as an acid or as a base. So we'll kind of see that again in just a little bit. So here we go. Some practice. So we're looking for conjugate acids. So these are the ones, if we look at our definition up above, it's our former base. It's the one that accepted the H plus. So we're going to be adding an H plus to each of these. And we have to take note of the charge, all right? So our charge is going to be very important, all right? So if we look at it like literally like adding it, so if I add an H plus to this, I'm going to get H2O. Or we could write it as OH2 if we wanted to kind of keep the same thing. Notice how our charge, we took a plus charge and a minus charge and added them and gave us 0 there. So we have to keep an eye on those charges. So again, let's take a little peek here. HCO3 with a minus, and we're going to add an H plus to this. So now we're going to have 2 H's because we added another H, and then we're going to have CO3, and that plus and minus added together to become neutral. Awesome. Okay, so let's keep rolling. Now we look at conjugate base, and up above we said conjugate base is the former acid, and it donated the H plus. So we're going to take an H plus off of each of these. So it's like subtracting an H plus. All right, so if we think of it like that, and think of it in terms of a math problem more than anything, right? Okay, so we'll be down to 2 H's, right, because we took one off, and then just an O, right, H2O. Notice a plus minus a plus gives me no charge, right? So we took the plus away. All right, and let's kind of see how that works on that next one here. So if we're going to take an H off, we're going to have no H's, and we're just going to have CO3. But now we have a minus, so we should have -2, or you could write it as 2 minus if you wanted to be fancy. Okay, so we removed an H plus to get us to our conjugate base. So let's look at the last part of this now that we've done a little bit of that there. Now it says in the following, we're supposed to identify the acid, the base, the conjugate acid, the conjugate base, and the conjugate acid base pairs. Feels like a lot, but it's not so bad. So get yourselves prepared. Okay, so here we go. We have to follow the H and kind of see what's happening. So HF, and let's just kind of connect up our conjugate acid base pairs right now. And I'm going to do that in a different color here. So HF on the other side becomes F minus. Does everybody agree with that? So HF loses that H. And we said before that when we lose an H, we are the acid. Okay? Donating an H is a Bronsted-Lowry acid. Okay? So now if we look at what's happening with water, water goes from H2O to H3O plus. So this is the one that gained the H, right? It went from 2 to 3, so it gained the H plus. All right. Now, on the other side, now we're looking at our products. This is going to be our conjugate acid or our conjugate base. So our conjugate acid is the one that accepted the H. So this is my conjugate acid because it accepted the H. It has one more H than it did on the other side. And then to finish this off, F minus is our conjugate base because it is the one that lost the H plus. And there you have it. All right, see you next time.